A sloth, a donkey, and a curious human. Send a prompt and see what they're doing. One hits record with a question on his mind. Two brothers pick it up, see what they find. Corn takes his time, Herman's got the facts. Back and forth, they never hold back. My weird prompts, come on in, that's where we begin. My weird prompts, glad you're here.
This episode was generated using artificial intelligence. Please verify facts.
My Weird Prompts is a community-driven initiative exploring how AI can fuel curiosity and uncover the fascinating ways our world works. GPU compute for this podcast is generously provided by Modal. Learn more at modal.com.
You know, Herman, I was sitting in the living room yesterday trying to upload that massive video file for our archive, and the Wi-Fi just blinked. It was only for a second, but it was enough to kill the upload. I found myself staring at my phone, seeing that beautiful 5G signal sitting right there at the top of the screen, and I thought, why on earth can my phone not just use both at the same time? Why is it an either-or situation in 2026? We have these incredibly powerful devices, yet they seem to have the networking intelligence of a dial-up modem from the 90s when it comes to managing multiple baths.
It is the eternal struggle of the mobile user corn. We have these incredible pocket supercomputers with multiple high-speed radios, yet the software treats them like they are in a jealous relationship. You can have one or the other, but heaven forbid you try to use both for the same task. It is the always connected dream versus the cold, hard reality of the Android single active interface routing table. I am Herman Poppleberry, by the way, and you are listening to My Weird Prompts. Our housemate Daniel actually sent us a prompt about this very thing this morning. He is looking for Android hardware that can handle advanced network aggregation and redundancy. Specifically, he wants to know if there is a way to do true multi-modem bonding, like what you get with a service like Speedify, but handled natively or more efficiently on the device itself.
It is a great question from Daniel, and it is one that gets to the heart of how these devices are actually built versus how we imagine they work. We always talk about being always connected, but the reality is more like being potentially connected to many things, but only actually talking to one at a time. Today, we are going to tear into the technical feasibility of multi-modem bonding on Android. We will look at why the hardware is the way it is, why the Android operating system fights you when you try to bond connections, and if there are any actual workarounds that do not involve carrying a server rack in your backpack.
And we should probably start by defining our terms because people often get confused between load balancing, failover, and true bonding. If you are just switching from Wi-Fi to cellular when the Wi-Fi dies, that is failover. If you are sending your YouTube traffic over Wi-Fi and your Spotify traffic over cellular, that is load balancing. But bonding? Bonding is the holy grail. That is taking two separate physical connections and treating them as one single fatter pipe. If you have a 50 megabit Wi-Fi connection and a 50 megabit 5G connection, true bonding gives you a 100 megabit pipe, where a single file transfer can use the full capacity of both. It is about throughput, but more importantly for someone like Daniel, it is about packet level redundancy.
Right, and that is what Daniel is after. He wants that high availability and high throughput. But before we get into the software side, Herman, let us talk about the hardware. When someone buys a modern flagship phone today, like a Pixel 10 Pro or one of the newer Samsung S26 models, they see two SIM slots, or an ESIM and a physical SIM. Does that mean there are actually two modems inside that phone?
Almost never. This is the first big hurdle. Most consumer phones use what is called DSDS, which stands for Dual SIM, Dual Standby. In this setup, you have two identities on the network, but they share a single set of radio hardware and a single baseband processor. Think of it like having two phone numbers but only one physical telephone. You can receive a call on either, but once you are talking on one, the other one is effectively busy or offline for data. There is a rarer technology called DSDA, or Dual SIM Dual Active, which actually has the hardware to maintain two active connections. We have seen this in some high-end gaming phones and certain international versions of flagships, using the latest Snapdragon X85 modems. But even then, manufacturers usually limit it to one data connection at a time because of the massive power draw and thermal issues.
That makes sense. I mean, these phones already get hot enough when you are just running a navigation app and charging at the same time. I could only imagine what happens when you have two 5G modems screaming at full power, trying to maintain separate carrier aggregations. But even if we find a unicorn device that has the physical hardware for dual active data, we run into the second big wall, which is the Android kernel and the way it handles networking.
This is where it gets really nerdy. Android is built on top of the Linux kernel, and the way Linux handles networking is through a routing table. In a standard Android setup, there is a component called the Connectivity Manager. Its whole job is to decide which interface is the default network. It is a very binary way of thinking. It says, okay, I see Wi-Fi is connected and has internet access, so Wi-Fi is now the king. Every single packet leaving this device, unless specified otherwise by a very specific app request, goes to the Wi-Fi interface. The cellular radio might stay in a low power state for calls and texts, but the data plane is effectively shut down for general use.
So even if I have a 5G signal and a Wi-Fi signal, the operating system is actively choosing to ignore one of them. It is not just that it is not bonding them, it is that it is intentionally keeping them separate to save battery and simplify the routing. If I wanted to change that, I would have to go in and start messing with the IP rule and IP root commands in the terminal, right?
You would, and that usually requires root access, which is becoming harder and harder to get on modern devices without breaking things like banking apps or your device integrity. But even with root, you cannot just tell the kernel to bond them and expect it to work. Traditional bonding requires the other end of the connection to understand what you are doing. If you send half a packet over Wi-Fi and half over cellular, the server at the other end, like Netflix or Google, is going to look at those two packets coming from two different IP addresses and say, I have no idea who you are or how these fit together. It would look like a security breach or just corrupted data.
And that is why services like Speedify exist. They act as the middleman. You send your traffic to their server over whatever connections you have, and their server reassembles them and sends them out to the internet as one coherent stream. But Daniel is asking if we can do this on-device for high availability and failover. If we cannot do true hardware bonding easily, what about the failover side? Android is notoriously slow at failing over. You know that moment when you leave your house, and your phone clings to the dying Wi-Fi signal in the driveway, even though you cannot actually load anything?
Oh, the driveway dead zone. It is a classic. That happens because the connectivity manager is waiting for the Wi-Fi signal to actually disconnect or reach a no internet state before it switches to cellular. It is trying to be polite and save your data plan, but it ends up just giving you a minute of dead air. There are some developer options in Android, like always keep mobile data active, which helps a little by keeping the cellular radio warmed up, but it still does not give you that seamless 0 millisecond failover that a professional setup would. The system still has to tear down the old socket and build a new one on the new interface, which drops any active streams or VPN connections.
So, if I am Daniel, and I am looking for a hardware solution, are there any specialized Android devices out there? I am thinking about those ruggedized tablets, or maybe industrial handhelds used in logistics. Do those have better multimodem support?
There are some niche industrial devices from companies like Zebra or Panasonic that have more robust networking stacks, but even those usually focus on better roaming between Wi-Fi access points rather than bonding cellular and Wi-Fi. The truth is, the smartphone form factor is just fundamentally poorly suited for this. Think about the antennas. To have two 5G modems working at peak efficiency simultaneously, you need enough physical separation between the antennas so they do not interfere with each other. In a 6-inch phone, you just do not have the real estate. You end up with desensitization, where the transmission from one modem drowns out the reception on the other.
That is a really important point. It is not just about the silicon, it is about the physics of radio waves. It reminds me of what we discussed back in episode 885, when we were talking about building that portable enterprise network in a backpack. In that scenario, we were using dedicated routers like those from Peplink or Teltonica. Those devices are designed from the ground up to have multiple modems, multiple external antennas with proper shielding, and the processing power to handle the encapsulation needed for bonding. They are not trying to fit in a pocket, so they can actually solve the physics problem.
And that is really the direction I think Daniel should look. Instead of trying to force an Android phone to be a multi-WAN aggregator, you use a dedicated piece of hardware to do the heavy lifting. But let us say Daniel is determined to stay on the device. There is one interesting workaround that involves the USB-C port. Most modern Android phones support USB tethering, but they also support USB host mode. In theory, you could plug a 5G dongle into the bottom of your phone.
Wait, really? Would Android actually recognize a second cellular modem plugged in via USB and let you use it alongside the internal one?
It is hit or miss. It depends entirely on whether the manufacturer included the drivers for that specific USB modem in the kernel. If you are lucky and you have a phone with good driver support, the phone sees it as an Ethernet interface. Now you have two interfaces, your internal cellular modem and an external Ethernet over USB modem. At that point, an app like Speedify can actually see both and bond them, but you are still running a software-defined overlay. You are not getting hardware-level aggregation. You are just giving the software two pipes to work with.
And you are also carrying a dongle hanging off your phone, which kind of ruins the portability. Plus, the battery drain would be astronomical. I mean, you are powering an external 5G modem from the phone's battery, while the phone's own internal radios are also screaming. You would probably get about 45 minutes of use before the phone shuts down from heat or low battery. It is a very mad scientist way to solve the problem.
Probably less if you are in a warm climate like we are here in Jerusalem. The thermal throttling would kick in almost immediately. The phone would start slowing down the CPU to stay cool, which then hurts your throughput on the bonding tunnel because encryption and packet reassembly are CPU-intensive tasks. It is a cascading failure of efficiency. This is why, when you look at professional bonding rigs, they are basically a large battery with some modems and a fan attached to them.
So, it sounds like the hardware-level dream of having a single Android device that just natively bonds multiple connections is still a bit of a fantasy because of the way the consumer market is structured. Manufacturers prioritize thinness, battery life, and cost over the niche needs of power users who want 100% uptime. But there is a second part to Daniel's question about multi-WAN failover for high availability. If we cannot bond for speed, can we at least get more reliable failover directly on the device?
There are some tools for that, but they are mostly in the realm of advanced networking apps that use the VPN API. This is a clever trick. Since Android only allows one default network, these apps create a local VPN. To the rest of the system, it looks like you are just connected to a VPN. But inside that VPN layer, the app is actually managing multiple connections. It can monitor the latency and packet loss on both Wi-Fi and cellular simultaneously. If it sees the Wi-Fi start to degrade, it can start routing packets over the cellular connection before the Wi-Fi actually drops. This is what Speedify does, and it is honestly the best experience you can get on a non-rooted device.
That is a much smarter approach than waiting for a total disconnect. It is like having a scout out ahead of the main army, checking for traps. But even then, you are limited by the Android VPN framework, which can sometimes be a bottleneck for very high-speed connections. I have noticed that when I run a VPN on my phone, my max throughput often drops, even if the VPN server itself is fast.
That is because of the context switching. Every packet has to be copied from the kernel to the VPN app and back again. On a desktop computer, that is trivial. On a mobile processor, even a powerful one, it adds up. Now, if Daniel is willing to look at hardware that is technically Android but not a phone, there are some interesting options. There are some specialized industrial routers and gateways that run a version of Android or a related Linux distro that actually have dual SIM slots with dual active modems. But at that point, you are basically buying a router that happens to run Android apps. It is the inverse of what he is asking for.
Which brings us back to the idea of the portable gateway. I think about the people who do live streaming from the field, like journalists or event coordinators. They use those bonded cellular units, like the ones from LiveU or Teradek. Those units often run a customized version of Android under the hood, but they are built around a massive battery and multiple high-gain antennas. They are the living proof that to do this well, you need to abandon the smartphone form factor. They use a technique called multipath TCP, or MPTCP, which is a standard that allows a single TCP connection to use multiple paths. Android actually has some MPTCP support in the kernel, but it is rarely exposed to the user.
That is a deep cut, Corn. MPTCP is fascinating. Apple actually uses it for Siri and Apple Music to handle the transition between Wi-Fi and cellular without dropping the connection. Google uses a similar technology called QUIC, which is a UDP-based protocol that can handle IP address changes more gracefully. But again, these are application-level fixes. They do not give you a big pipe for the whole system. They just make specific apps feel more stable.
It is about modularity. And from a conservative standpoint, I actually like that approach better. It is more resilient. If your phone breaks, you can swap it out and still have your high-end networking hub. If everything is integrated into one device, and that device's screen cracks or the battery swells, you have lost your entire communication stack. I would rather have a solid, American-made networking gateway that I can connect any device to.
I agree. And speaking of resilience, we should talk about the software side of failover for a second. There is a project called OpenRT, which is an open source router operating system. You can actually run OpenRT on some handheld devices, or more commonly, on a small travel router like those from gl.inet. These little routers, like the Barrel AX or the Slate AX, are about the size of a pack of cards. They run on USB power, and they have incredible multi-WAN support. You can plug your Android phone into the router via USB, tell the phone to tether, and the router treats the phone as one WAN connection. Then you can plug a 5G dongle into the other USB port, or use the router's own internal modem and bond them right there using a plugin called MWAN3.
So the router becomes the aggregator, and your phone just connects to the router via Wi-Fi. That seems like the most practical daily carry version of this. You get the benefits of bonding, you save your phone's battery because it is just doing standard Wi-Fi, and you have a dedicated device that is actually designed to handle the heat and the routing logic. Plus, you can use the router's antennas, which are usually much better than the ones crammed inside a phone.
And that setup is much more robust. If you are in a situation where you need high availability, like Daniel is suggesting, you want a device whose only job is to stay connected. Your phone has too many other things going on. It is busy checking for notifications, updating apps in the background, and managing the display. A dedicated travel router just sits there and grinds through packets. It is a set it and forget it solution.
Let us look at the second order effects for a minute. If you actually manage to get a bonded setup working, whether it is on the device or through a gateway, what does that do to the way you use the internet? I think most people do not realize how much of our web experience is optimized for single connection, high latency mobile links. When you suddenly have a rock-solid, low-latency bonded pipe, everything changes.
It really does. One of the biggest things is the disappearance of the buffer wheel. When you are bonding, you are not just getting more speed, you are getting more consistency. Most of the stuttering we experience online isn't because the average speed is too low, it is because of jitter or momentary packet loss. Bonding fixes that because the chance of both connections having a packet loss event at the exact same millisecond is very low. It creates this incredibly smooth experience that feels more like being on a fiber connection than being on mobile data. It is especially noticeable for things like Zoom calls or online gaming where latency spikes are the enemy.
But there is a downside, right? Data usage. If you are bonding two connections, you are potentially doubling your data consumption for the same tasks because of the overhead of the bonding protocol. Every packet has to be wrapped in a new header, and there is a lot of keep alive traffic to monitor the health of both links. For someone with a limited data plan, that could be a nasty surprise at the end of the month.
That is a very real concern. Most bonding protocols add about 5 to 10% overhead. It is not massive, but it is not nothing. And if you are using a service like Speedify, you are also paying for their subscription on top of your 2 data plans. So it is definitely a pro solution for people who really need that reliability, not something for the average person who just wants to scroll through social media a little faster. You also have to consider the IP reputation issue. Since all your traffic is coming out of a bonding server's IP address, some websites might flag you as using a VPN or a proxy and throw up extra CAPTCHAs.
So, to go back to Daniel's specific question about hardware, If he's looking for a single device, he is probably going to be disappointed by the current flagship market. Even the most expensive phones are still fundamentally DSDS or limited DSDA. But if he is willing to look at the Android Plus category, there are options. Herman, what would be your dream setup for someone who wants this multi-modem bonding experience without carrying a full backpack?
If I wanted to keep it as portable as possible, I would get a high-end Android phone with a good USB controller, like a Sony Xperia 1 Mark VII or a Samsung S26 Ultra. Then I would pair it with one of those ultra-portable 5G travel routers that supports USB tethering. I would tether the phone to the router and let the router handle the bonding with its own internal SIM and the phone's connection. You can Velcro the router to the back of the phone case if you really want that all-in-one feel. It looks a bit like a Frankenstein device, but it will outperform any single phone on the market for connectivity.
It is the cyberpunk aesthetic. I love it. But it also highlights the architectural limitation of Android itself. Until Google decides that multi-WAN aggregation is a core feature that they want to support in the AOSP source code, we are always going to be fighting the operating system. Do you think we will ever see that? With the rise of 5G slicing and more enterprise-focused mobile use cases, is there a world where Android just natively supports bonding?
I think we might see a version of it through 5G slicing. Instead of bonding two different physical connections, the modem might maintain two different slices of the same 5G network. One slice for your low latency mission critical data and another for your background downloads. This is part of the 5G standalone spec that is finally being rolled out properly in 2026. It is not exactly what Daniel is asking for, but it solves the same problem of reliability and throughput. As for bonding a Wi-Fi signal from a coffee shop with a cellular signal from a tower, I think the carriers actually hate that idea. They want you on their network, or they want you offloading to Wi-Fi to save them capacity. They do not necessarily want you using both, because it makes the billing and the network management much more complex.
That is a cynical but probably accurate take. The carriers have a lot of say in how these devices are configured, especially in the US market. They want to control the experience. If you are bonding, you are effectively bypassing their ability to prioritize or throttle specific types of traffic because it is all hidden inside that encrypted bonding tunnel. It takes the power away from the ISP and gives it back to the user, which is exactly why we like it.
It is a win for the user and a headache for the network operator. But for the users like us, especially those of us who live in places where infrastructure can be unpredictable, that independence is worth the effort. Whether you are in a safe room in Jerusalem or a remote cabin in the woods, having a redundant, bonded connection is a game changer. It is about taking control of your own last mile of connectivity.
I think we have covered the hardware limitations pretty thoroughly. It is not that the technology doesn't exist, it is that it has been intentionally left out of consumer devices for a variety of thermal, power, and market-driven reasons. But the workarounds, while a bit clunky, are actually quite powerful if you're willing to put in the effort. For Daniel, the takeaway is clear. Stop looking for the perfect phone and start looking for the perfect bridge.
They are. And for Daniel, the takeaway is, use the phone for what it is good at, the interface and the apps, and let a dedicated piece of networking gear handle the radios. It is a more professional, more resilient, and ultimately more satisfying solution. If you really need high availability, you need to move the complexity out of the handheld and into the infrastructure.
I think that is a great place to start wrapping this up. We have gone from the driveway dead zone to the intricacies of the Linux kernel and the physics of antenna isolation. It is amazing how much complexity is hidden behind that little signal strength icon on our phones. It is a reminder that wireless is never really simple.
It really is. And it is a reminder that even in 2026, we are still in the relatively early days of truly seamless global connectivity. We have the speed, but we are still working on the reliability. We are getting there, one packet at a time.
Well, if you have been listening to this and you have your own Frankenstein networking setup, we would love to hear about it. Or if you have a different way of tackling the multi-modem problem on Android, get in touch. You can find the contact form on our website at myweirdprompts.com.
And while you are there, you can check out the full archive of our episodes. If you enjoyed this deep dive into networking, you might want to check out episode 774, where we talked about the quest for vanilla, Android, and escaping all that vendor bloatware that often messes with these advanced settings.
And hey, if you're finding value in these discussions, do us a quick favor and leave a review on your podcast app or on Spotify. It really does help other people find the show, and we love reading the feedback. It keeps us motivated to keep digging into these technical rabbit holes.
It genuinely makes a difference for a show like ours. We appreciate the support from our regular listeners who have been with us through all these technical deep dives.
Definitely. You can also find us on Telegram if you want to get notified the second a new episode drops. Just search for My Weird Prompts and join the channel. We post all the updates there, along with links to the RSS feed for the old school subscribers.
All right, I think that covers it. Thanks to Daniel for sending in such a fascinating prompt. It was fun to dig into the guts of Android networking again. It is a topic that never really gets old because the goalposts keep moving.
This has been My Weird Prompts. I am Corn Poppleberry.
And I am Herman Poppleberry. Thanks for listening, and we will catch you in the next one.
See ya.
This episode was generated using Gemini Flash 3. Text-to-speech engine was Chatterbox.
Thanks for listening to our show, My Weird Prompts, where our thoughts go from slow takes to facts on cue. We change and fall.